Hello, it's Andrew again. Video 2 of the Designing a Robot for First Stronghold series. Alright, in this video I'm going to go over a little bit of the geometry sketches just to get a rough idea of what I want my robot to be, or just the general shape. And hopefully I can explain something that'll help you get an idea of how to design robots and sketches. I know Adam Hurd has a better video on how to design robots and sketches. And really, if you haven't seen his ramp series, which is like remote something assistance mentorship program, regardless of the acronym, it's a good thing to watch his entire video series. It's like mine but better in every way. So I would suggest, I'll probably link to that in the description. Alright, so what I'm doing here is I'm just getting started off with a side view of my robot. I always like watching the side, or designing from the side first. And I'm going to put that in the center. So this this blue rectangle up here, that's my 2x1 frame. I mostly will design using 2x1 pieces of frame. So I usually start with that. You don't have to if you don't. And this down here is my ground. I'm just going to make the ground 60 inches. Alright. And I don't know how long I want my robot to be. Really, it could be the length of a ball if I wanted it to be, because that's all I need to do is hold a single ball. But the longer it is, the more stable it is. So we'll see how that works out. It's got some wheels in here. I think it's going to be an 8-wheel drive. So I'll have, let's say, a 3/16 offset. I will put my wheel dimension as 8 inches. I'll make that, let's see, tangent there. And I'm going to do a 3/16 offset, so that'll be 3/32 below, but since I'm using the SolidWorks tool like that, I will go above. Make another wheel, same size, and I'll say that it's 3/16 total difference as well. As for the distance between them, let me see. So this is currently at 40-something inches. I want to minimize that. I also want to bring this closer to center. So the goal here is, oh wow, nope, that's bigger than I need it to be. Okay. The goal is I want my robot to be long, because the longer it is, in general, the more stable it's going to be. So going over obstacles can be a lot easier. However, with certain obstacles like the moat and the ramparts, more the moat and the rock wall, I mean, having your wheels close together also helps, because as soon as you have a gap in your frame between your wheels, you're more likely to get stuck there. Or as they called it this year, too good. That was interesting. So, want to make my robot long, but not too long. Like, that's too long. I need to mention this quick. At the same time, I want it to be, okay, that's what's making it long. Shouldn't be, though. It's not related in any way. Okay, point being, I want it to be long, but not too long. And I want it to be, I want the wheels to be close together. So I'm just going to do a little leg work, make some estimates here, and hope it's all goody-goody. I'm going to say like, okay, I'm trying to get a horizontal distance here. It's not being nice to me. Okay. So I'll have, just accounting for fluctuations in wheel diameter. So I'll have a 1/4 inch between my wheels. So I'm doing an 8-wheel drive. Then this inner wheel is going to have another wheel opposite it. So I'll do an 1/8 inch from the center, and that'll be 1/4 inch total. I may change that later on, and then that's the nice thing about SolidWorks is you can change it. And then say I want the come on, keyboard shortcuts. There you go. Just clicking F instead of D. I want the horizontal distance to be about a 1/4 inch distance between what are these 8-inch wheels. So two 4-inch radii and a 1/4 inch. So that will be 8.25. Nice. And why is this defined? Okay, so maybe this does have a definition somewhere. What's this horizontal to? It shouldn't be horizontal to anything. It's coincident to that. Okay. Cool. That's why. Nice, nice. How big is this? 30. Okay. One thing I want to do is I want to make sure my frame is actually pretty well within my wheel. I want my wheel to be what's sticking out the most. And that way when I go over a bump or I go over an obstacle, the wheel just it impacts first and the wheel deforms and it pushes the robot up. I'm not hitting a hard frame, I'm hitting a pneumatic wheel. That's going to be pretty soft. So that'll work out good. I want most of my robot to be, or I want my center of gravity to be down low. So that's something to think about as well. I'm going to go with a nice clean number. 30 sounds nice. 30 is a clean number. So I'm gonna mirror these over. I draw that center line. I have a horizontal one and a vertical one as well in the center point rectangle, just so I can mirror things over, or I can reference things from the center. Alright. And just looking at this, I'm going to say maybe a 1/4 inch is a little too small. So I will say 3/8. And granted, I have no experience in this whatsoever. Like, I've designed quite a few drivetrains, especially for Stronghold. However, I did not use 8-inch pneumatic wheels, and the 6-inch pneumatic wheels we used on 1323 this year that I helped with the design work for did not expand as much as the 8-inch ones. So we'll see how that goes. I think that'll be a rough approximation. And this is just a pretend robot. This is just for practice. So it'll work out. So this is going to be my drive base. Pretty straightforward. What's nice about this, actually I'm going to increase the floor size. There. Is now I can model a ball, which is going to be 8 inches in diameter. It's nominally 8 inches. And I can sort of see how it'll interact with my robot. Now, of course, I will need my bumpers to come out a little bit further. So I'm going to measure the total distance of my wheels. Okay, 33 1/8. So I like doing everything in measurements of halves because I like 1/2 inch hole patterns. So I'm going to say 33 1/2 is going to be my total outside distance. And I'll model that by using a center line, putting it above the origin, or putting it vertical to my to the center of that piece of tube. Okay. Nope, it was not 30. It was very much not 30 because that's the tube size, 33. Okay, cool. Nope, I edited the wrong thing. Cool. So that's going to be whatever my maximum dimension is. That's going to be where my bumpers connect. And just to help around with some stuff, this isn't like a frame member. That's why it's a construction line. This will be sort of my max dimension in my length. And of course, since this is a two-dimensional drawing from the side, I can't show the width, but I can show the height. So I'm going to use this to show my maximum height, and I'm saying that's going to be 14 inches. I'm just going to leave that up there. Cool. Now, the interesting part is using this. I want to create a robot that can ideally pick up this ball from either side, transport it through the entire robot with active control, and spit it out the other side, or spit it out whatever side. I'm already having an idea of how that'll do, but I don't want to plan too much yet. Alright, so we have that. I guess the next thing to do would be an intake. That'll be nice, because I don't really have a shooter. So intake for this, I was actually really fortunate this year because I got to mentor two extraordinary teams, one being 1323, the other being 971, that's Spartan Robotics out of Mountain View in California. And I would say arguably 971 had the best intake this entire year. It was the fastest, it was the most effective, it was extremely simple for a 971 subassembly. I mean, no, that was extremely simple for anything 971 ever made. More their robots were like that, then I'd understand them more. I love them though. Okay. So, actually, before I get to the intake, I'm gonna... Ooh, do I want to do that? Do I want to do that? Do I want to do that? Ooh. Okay, what I'm debating is, I have this idea of actually using that construction line, that exactly 14 inches above, as a framing member, a piece of 1x1 probably. And that'll just show my maximum height already, and I can show how that's connected to the drivetrain. That stuff. I will think about this. Let's see. Alright, let's just go with the intake for right now. We're trying to get that fitted. So I'm gonna, like I was saying, 971 had probably the best intake, and it used 4-inch Mechanism and Omni wheels. So that worked really well. I'm just gonna copy that because it's the off season and everything's legal. Now, this is gonna be at some height. I'm just going to make an estimate as to what compression works best. I really don't know. But I need to figure out how I want to model whatever I use to intake the ball into the robot. So I'm going to have some kind of 4-inch Mechanism wheel that will go out of the frame at some distance. There is actually an extension distance, a maximum extension, that I don't know off the top of my head. I don't feel like I'll need it, so that'll be fine. I will, however, I forgot to do this initially, I'll model the bumpers, and that's super simple, but it's always good to do. So the way I like to model bumpers, start with a rectangle. This is actually the way I learned from Adam Hurd in his 973 ramp videos. And I'll give it a thickness of 3 1/4, because that's 2.5-inch diameter pool noodle plus 3/4 inch plywood. I'll make it 5 inches tall, because that's 2.5-inch pool noodles added up. Use a 1 1/4 radius, because that's how it works out to be. Oh, ew. Fix that. Yeah, so it's 5. So that's a pretty simple model bumper. And I'm not exactly sure where I want it yet. Maybe I'll have it up high. Ideally it's down low, but I don't know, I kind of want to experiment. And I think you could have your bumpers between 2 and 12 inches this year. So seeing how we could play around with that would be interesting. I will, however, I'll put that vertical there, because that's going to be my total outside. And then for fun, what I call fun, put it, oh, how far off the ground do I want this? 6 inches off the ground? I don't know, is that unreasonable? I don't think so. And I can always change this later. And the bumpers, I'm not doing it over the bumper intake, so that's not going to affect my ball. But it's always nice just to have an idea of where your robot is. So my ideal ball will go into the robot, up into the frame. I actually need to go up too far because the frame's not going to go in all the way, or won't yet. Question I have for myself is it at some point is this ball going to sit on top of this frame, on top of this 2x1? And the reason I'm asking is because I have exactly 8.906. Okay, yeah, I have a little under 9 inches, which I can work with, but don't want to push it. So I'm thinking, how much compression do I want on this? Oh, okay, fine, do that. What am I thinking? Oh, need to have something that can bring the ball from the ground up into the robot. I always like an active roller. So I'm gonna put. Ooh, actually, interesting thing I could try out is I could have this. That's technically within my frame. So what I'm thinking right now is typically if I were to have a roller down low that would help roll the ball up into the robot, I'd have it somewhere within the frame, which is within this piece of 2x1. And the reason I'm not so sure about that now, or I don't think it's completely necessary, is because if it's somewhere outside or out further, it's still within the frame perimeter, and the wheel still somewhat protects it. All that is prime bump location, where if it's going over a defense, it'll hit right there. So that's probably not a good idea. Another idea I've had, and I'm unsure of its effectiveness, is side rollers. Just something from the side that'll roll a ball in. The advantage of that is you're not necessarily putting something too low, and whatever your ramp is, you could have be polycarb, something simple, something that could flex. Where worst case scenario, the ball touches the polycarb and the side rollers hit somewhere around the top and bring it in. This is actually more difficult than I thought, though. So, let's see. How far are we into recording? Okay, we're close to 20 minutes in, a little 18 and a half minutes. I'm going to stop this video right here and do some brainstorming, and hopefully I'll get back in a few minutes. But just a summary of what we've accomplished during this video. We've modeled out our frame, a side profile of our frame and where our wheels are going to be. We've modeled out our maximum dimension, our height. We've modeled out a bumper, a makeshift mechanism wheel roller, and the ball. And from there, we're going to play around with different geometry and work around with ideas on how to get the ball into the robot. Alright, that'll be all for now. Thanks for watching.